Assalamualaikum warahmatullahi wabarakatuh. My name is Maliki bin Nasaruddin, matrix number 2023698836, and I will present and discuss about the answer of question 4A1. So, the question is, the probability distribution function for a random variable x is given by fx equal to e to the power of negative x squared over 4 over set 4 pi, where x is in between negative infinity and positive infinity, and fx is also 0 elsewhere. So for A1, show that the distribution of y equal to x squared is a gamma distribution with parameters alpha equal to 1 over 2 and beta equal to 4 using a transformation techniques. First, we need to find the inverse function of y, where cumulative probability density function is equal to probability of random variable y less than or equal to value y. Then we substitute y equal to x squared into the function. Now, the cumulative probability density function is equals to probability of x squared lower or equal to value y. Finally, we get a cumulative probability density function is equal to the probability of a random variable x between negative set y and set y. The graph on the right is the graph of y equal to x squared, where blue line represent the x equal to set y and red line represent x equal to negative set y. And the shaded area represent the cumulative probability density function. By observing the graph of y equal to x to the power of 2, we can determine the upper limit, which is set y, and the lower limit, which is negative set y. Then, we can apply the transformation formula, which is probability density function equals to f of upper limit times the absolute of the derivative of upper limit plus f of lower limit times the absolute of the derivative of lower limit. We can substitute the value of upper limit and lower limit into the given function f of x. And we also find the derivatives of the upper limit and the lower limit. Then we solve the absolute where negative sign turn to positive sign. Set negative set y square and set y square from both terms can just be y. Set 4 pi from both terms also can be separated into set pi and 4 to the power of 1 over 2. Since both terms is equal, we can add them. This is because, for example, a plus a plus a plus a for n times is equal to na. And now it becomes 2 times e to the power of negative y over 4 over set pi times 4 to the power of 1 over 2 times 1 over 2 times y to the power of negative 1 over 2. After that, we can simplify it. We can cancel the 2's and set pi is equivalent to the gamma of 1 over 2. So this is our distribution. And from the graph, we can say that y is greater than 0. From appendix of gamma distribution, we can say that f of x is equal to 1 over gamma of alpha times beta power of alpha times x power of alpha minus 1 times exponent power of negative x over beta. This shows that y follow gamma distribution with alpha of 1 over 2 and beta of 4.
Hi, and Assalamualaikum. My name is Ainawati Shamtisul Amri, and for this video, I will explain for question number 4A2, which is the question asks us to find the moment generating function of W and state the distribution of W. So let's start with the given information. We are given that each y sub I follows a gamma distribution with alpha equal to 1 over 2 and beta equal to 4. So we are asked to find the moment generating function of W where W is equal to 1 over 2 times the sum of yi sub from I equal to 4 until n. Next, we need to find the MGF of the gamma distribution. So let's recall the MGF formula for the gamma distribution. If y sub I follows gamma with the parameter alpha and beta, and then the MGF is bracket 1 minus beta times t, and we close bracket to the power of negative alpha. So in this case, alpha is 1 over 2 and beta is 4. So the MGF becomes bracket 1 minus 4t close bracket to the power of negative 1 over 2. So now we find the MGF of W. We start with the definition. MW of t equal to the expected value of e to the power of t times W. And then we substitute W into the equation, which gives us e to the power of t over 2 times the sum of y sub I from I equal 4 to n. Because all the sub I values are independent, we can split the expectation into a product. That means we get a product of the MGF of y sub I, but evaluated at t over 2. So we write MW of t equal to the product from I equal 4 to n of my sub I of t over 2. So the next slide show the continuous for the MGF of W. Earlier we found that the MGF of y sub I is bracket 1 minus 2t close bracket to the power of negative 1 over 2. And now from I equal to 4 to n, we are summing n minus 3 values. So we will multiply the same expression n minus 3 times. This will give MW of t equal to the bracket 1 minus 2t close bracket to the power of negative open bracket n minus 3 close bracket over 2. So, as we can see, this is the same as the MGF of chi-square distribution, with n minus 3 is the degree of freedom. So the final conclusion is W follow a chi-square distribution with n minus 3 degrees of freedom.
Assalamualaikum warahmatullahi wabarakatuh. So my name is Nur Aina Maria. Okay, now we will proceed with question 4b. So the question states that suppose random variable W are random sample of size 13 from taken from a normal population with unknown population mean and variance. So for one Roman, it states to show that the capital T follow T distribution with 12 degree of freedom, where S is the sample deviation. Based on the equation, we are given with n equals to 13 and W follow normal distribution. So based on the theorem for T distribution, it states that if random variable W with I degree of freedom follow normal distribution, then the following equation follow T distribution with degree of freedom n minus 1. So from the equation, we have W bar. So first, we need to know W bar follow which distribution. And from theorem 2.2, we know that when W follow normal distribution, then W bar follow normal distribution too. And then Z equals to W bar minus mu divided by standard deviation over square root of n follow standard normal. Also, when W follow normal distribution, then n minus 1 s squared over sigma squared follow chi-squared distribution with degree of freedom n minus 1. Then we subject the equation to y for easier understanding. Then from theorem 2.10, we know that when we have standard normal and chi-squared distribution, then we divide the distribution, it will give us T distribution. We know that when we divide that z over square root of y over the degree of freedom with n minus 1, we will obtain the following equation, and then we simplify and we will get that W bar minus mu over S over square root of n follow t n minus 1 distribution. So, since the equation states that the n equals to 13, we substitute 13 into the equation and we will get the capital T equals to W bar minus mu over S divided by square root of 13 follow T distribution with degree of freedom 12, which are proved by the equation.
Hi, I'm Nur Kistina Hani binti Ahmad Tabrani, and I will continue with the last question, which is 4b2. So this question asks us to find a derivative of 1 minus alpha times 100% confidence interval for mu. So what is the question all about? This is actually the derivation of the confidence interval for the population mean, which is mu, when using a small sample size with unknown population standard deviation. So in this question, we use the T distribution. One, because of the small sample size. Second, because of the unknown sigma. And the third one, for question 4b1, we were asked to show that W bar minus mu over S over square root of 13 is follow the T distribution. So that's why we use the T distribution. So this question is to find a range of values where a true population mean, which is mu, is likely to fall with a confidence level of 1 minus alpha times 100%. So the first one, I will explain about the graph. So this graph actually shows the T distribution curve with bell shape. And the important part of this graph is actually this negative T alpha over 2 n minus 1 and T alpha over 2 n minus 1. These are actually a critical values that mark the boundaries of the middle 1 minus alpha probability. So the middle area is 1 minus alpha, and this graph is actually shows two tail areas which each contain alpha over 2. So we proceed with the working. So for step 1, I will explain about all the variables that follow this distribution. So W bar is actually the sample mean, and S is sample standard deviation, and square root of 13 is actually equals to square root of 9, which is the sample size, and 12 is the degree of freedom, which is n minus 1. So for step 2, I set the probability condition, so which is the probability that T score falls between negative T alpha over 2 and negative T alpha over 2 with 12 degree of freedom, and T alpha over 2 with 12 degree of freedom is equals to 1 minus alpha. So for step 3, I multiply both sides by S over square root of 13 to remove the denominator. So now the inequality focus only on W bar minus mu. So for step 4, I rearrange the inequality to isolate only negative mu. And step 5, I flip the inequality sign by multiply both sides by negative 1 to bring mu to the center. So the final step, I rearrange the inequality to get the standard confidence interval form of mu. So this is the final answer for 1 minus alpha times 100% confidence interval formula for mu, which is W bar minus T alpha over 2 follows 12 degree of freedom times S over square root of 13 is less than W bar plus T alpha over 2 with 12 degree of freedom times S over square root of 13. I think that's all from me. Thank you.